Let's go over the second PhET Lab. If you are stuck or have questions, make sure that you have the simulation available. We are using the real molecules screen. If we go through the simulation, we can compare the modeled bond angle and the real bond angle. So let's make sure all of the correct buttons are clicked. And let's compare the model bond angle and the real bond angle. I am going to check CO2 next. The model and real bond angle are identical. So sometimes the angles are the same and sometimes they're different. So I checked all of the molecules and here's what I have. Water, SO2, ClF3, NH3, SF4, and BrF5 all have real bond angles smaller than the model. All of these molecules have unbonded lone pair electrons, and the angle is always smaller than the theoretical angle. Interesting. Question 2 has a linear electron geometry and molecule geometry. How do I know? I checked these tabs right here. And by checking this tab, I can see that the bond angle is 180 degrees. Let's take a look at the third problem. For each of these, you needed to find the molecule, making sure that the electron geometry, molecule geometry, and bond angle boxes were all checked. That gave me the first 3 columns. A ball and stick model of the molecule shows the structure for each of the molecules. On the last page, we're using the same chart that you saw in the notes. The first thing I did for each was draw the Lewis structures. For CCl4, I drew the structure. We are only concerned about the central atom. Carbon has 4 bonds and no unbonded electrons. We are ignoring all of the lone pairs on chlorines because chlorine is not the central atom. I find 4 electron domains on the chart, no lone pairs on the central atom. And I follow across until I find that it is tetrahedral. This is what it looks like if I build it using the PhET model. PF3 has 3 PF bonds and a pair of electrons around phosphorus. This means it has 4 electron domains and 1 lone pair. Following across, the molecule has a trigonal pyramidal shape. OF2 has 2 bonds and 2 lone pair, so it has 4 electron domains, and it is bent. It will have an angle less than 109.5 degrees and probably even less than the PF3 bond angle. Now let's look at the challenge problems. For these, I am only using the chart. The carbon in red has 4 bonds, but only 3 electron domains. The double bond counts as only 1 electron domain. 3 electron domains and no lone pairs lead us to a trigonal planar geometry around the carbon in red. In the second molecule, the carbon in red has only 2 electron domains. It must be linear with a 180 degree HCH bond angle. The last molecule has two different geometries. The carbon is similar to the first carbon. It has two single bonds and a double bond. 3 electron domains with no lone pair means that the carbon has a trigonal planar geometry. The nitrogen also has 3 electron domains, but in this case, one of them is a lone pair of electrons. So following the chart, we can see that it is a bent or angular shape around the nitrogen. The HNC bond angle will be a little smaller than the HCN bond angle because nitrogen has a lone pair of electrons. Well, I hope that helped. Please make sure you ask any questions.